Hello again. Let's have a look at question number 17 on your pre-mock pack. And this one is about vectors. So I'm going to have to obviously give you a quick crash course on what are vectors. But let's read the question first. So it's giving me this parallelogram with a horn. So it's like a parallelogram unicorn. And OACB is a parallelogram with a horn. M is the midpoint of AC, so it's been annotated on the diagram for you. C is the midpoint of the straight line BCX. So you see the straight line here, and you know C is the midpoint, and it's giving me the fact that OA, so this is vector notation, this arrow above the OA, that means the vector OA is equal to lowercase a. And OB, which is this line here, is equal to lowercase b. So what are vectors? Obviously, let's finish with the question. First, it says, prove that OMX is a straight line. So OMX, so this bit here, all the way to the end, OMX is a straight line. What are vectors? So the way I like to think about vectors tell you where you're going and which way you're going. What's the direction, what's the route, what's your journey that you're traveling on. So for example, in this case, in the OA, vector OA, it's telling me that to get from O to A, I'm going to have to travel A units, whatever those may be. And for the second one, to get from O to B, so from O to B, I'm going to have to travel B units. Now, let's have a bit of a practice because I feel like I'm going to need this. Now, let's say I wanted actually to get from A to B vector, obviously. So to get from A to B in vector notation, I would have to go the way that I know, obviously, in terms of A and B, lowercase a and lowercase b. So I'd have to go from A to O first. So I would have to go from A to O, and examiners absolutely love it when you're telling them which way you're going and how you're doing it. So that's why I'm doing these vector notation thingies. So I'm going from A to O, and then I'm going from O to B, so plus OB. Now, vectors also have a direction, and the arrow that's on the line tells you the direction of the vector. So because I'm going from O to A, I'm going in a positive vector direction because I'm going with the arrow. If I was going from A to O, I would be going the opposite direction. So I'd be going a negative A because I'm going against the arrow. So let's try to have a look at this AB here. So I told them that AB is equal to AO. And we said that if I'm going from A to O, I'm going against the arrow, so I'm going minus A. And if I'm going from O to B, I'm going with the arrow, so I'm going plus B units. Like that. I don't even know if I need that, but I think you guys need a bit of practice. So, because you've got a parallelogram here, we can annotate what we also know. Like, for example, if I know from O to A, I've got A units. From B to C is going to also be A because they're the same, right? The opposite sides in a parallelogram are equal. And if I know that OB is B, so to get from O to B I go B units, it's going to be exactly the same to get from A to C. That's also going to be B units. And then I've got some midpoints and stuff like that in there. So what you need to prove that a line is a straight line when you're dealing with vectors. So you need to prove that parts of the line, different parts of the line, are multiples of each other. And you also need to prove that these different parts of your line have a point in common. And for me it's easy because I know that point M is a point in common on my line. So I'm going to try to work out OX, so the whole of the line, so OX. And I'm also going to try to work out Let's say OM, because that looks easy. And if I play my cards right, and if I do this correctly, I should show that OX is a multiple of OM in terms of A and B. So I'm going to start with OM. This is what we're aiming for. And now we know. I'm going to start with OM. Vector notation. So remember to tell your examiner which way you're going. So to get from O to M, I'm going to go from O to A first. So OA. And then from A, I'm going to go to M. So plus AM. Now let's give that in terms of A and B, lowercase a and lowercase b. So to get from O to A, I'm going with the arrow and I'm going A, units. Now to get from A to M, remember M is the midpoint of AC, and I know AC is actually B units, but I don't want to go all the way, I just want to go halfway, so half of B. And this is OM in terms of A and B. Now we said we're also going to work out OX. So to get from O to X, there's quite a few ways that I could go. And I'm going to use some information they give me here, and that says C is the midpoint of the straight line. So this is the midpoint of this entire BX line. So if I know that from B to C is A, then I know that from C to X is also A, because C is the midpoint. Okay, so I've got that bit as well. So now I'm telling the examiner that to get from O to X, I'm going to go from O to B. Then I'm going to go from B to C. And then I'm going to go from C to X. I could have said the BX in one go, because that would be equal to 2A, but I just want to do it bit by bit, so hopefully you guys can follow along nicely. All right, so OX is equal to OB, we said, is B, lowercase b. BC is lowercase a. And CX is lowercase a again. If I simplify that, I get that OX is equal to 2A plus B. Now, if I look at the relationship between OM, I'm going to use my fanciful unicorn pen. If I look at the relationship between OM and OX, I notice that if I multiply OM by 2, I get OX. And I need to do it better. Okay, so how do I tell that to the examiner? I'm going to say that OX, so vector OX is 2 times vector OM. And I'm also going to say that point M is common. Okay. In brackets, I would say that multiples of each other. And therefore OMX is a straight line. Okay, so that's a PPQ slash quick introduction to vectors. I will see you shortly for question number 18. Bye.